Hi, my name is Stephen, and wanted to give a quick intro to Joist, which is a TypeScript ORM for Postgre that we've been building for a few years now. And yeah, wanted to cover three main things. One is how Joist focuses on building great domain models and kind of what that means and what the entities look like, very briefly. And then an overview of two of our main features. One is the type-safe loading of relations from the database, and then also our bulletproof N+1 prevention. So let's start with the first one. Just what do we mean by domain models and entities, and kind of what does that look like? And so we'll start with, in our sample project here, just an overview of the database schema. So um, this is a node pg migrate migration, which is the migration project that we use. You can use whatever you want. This is what our sample uses. And we're just going to make two tables, authors and books. Authors have a first name and a last name, and books have a title with an author. This create entity table is a helper method that Joist has. You can use it if you want. It just adds an ID column, updated at and deleted at. All those are optional. The ID column is required, but the updated and deleted at are optional. So this is our database schema, really pretty simple. And so what we mean by creating a domain model and entities is Joist will, you run a codegen step, and Joist will read your schema and create domain objects for it. So here's our author domain object and our book domain object. And you can see they're really nice and clean. Nothing in the actual class itself yet. This is where you would put your application's specific business logic and validation rules and that thing, and that sort of stuff. And then all of the boilerplate, isn't annotations or, XML config files or something like this. All of the boilerplate is in this author codegen that will get overwritten every time you run Joist codegen that just looks at your database schema and puts the latest fields here. So you can see this has like getters and setters for the IDs and the first name, last name. And then also the relations. So like the author has a relation pointing to books. And if we look at the book codegen real quick, it has its own author relation pointing kind of back at the author. So these are our entities, very simple so far, but let's look at how we interact with them. So here's a author test that just shows creating authors and books. Joist uses a unit of work pattern, which we call the entity manager, but the unit of work for a given request, so it's usually an HTTP request, keeps track of all of the work that you've done, that you intend to do, and then sends it to the database all at once. So here you can see we're creating an author with first name, another author, first name, a book for the first author, and a book for the second author. And then the entity manager flush is what tells Joist to go look for what you've changed and create the SQL statements to go into the database for that. So you can see here we've got 5. We do all of the updates within a transaction. And then the second one is getting IDs for any of the new entities. So this is 2 authors and 2 books. We get the IDs for those in one statement. And then we do batch. These are batch inserts. They could also be batch updates or batch deletes for the entities that you've changed. So this insert is actually inserting 2 authors at once, the first one and the second one, and then the books is also doing the second one. So that's really handy. If you've changed 30 books or 50 books or whatever, it'll be just kind of one insert or one update to do all of the work. And yeah, so that's kind of working with the entities. Let's show just a little bit of why you might like to use a domain model approach. One of the big things that we like is adding validation rules. So here's our author class. Let's add our first really simple validation rule. This placeholder you can kind of delete. It's there to just keep the config import around until you actually use it. So there's a lot more to talk about for validation rules, but this is a really simple one. It just runs every time first name changes. And every time first name changes, we'll see if it's less than 3, and if it's less than 3, we'll throw an error. Really pretty basic. But what's nice about domain models and entities is anywhere in your code that you're making authors or updating authors, now we'll always have this validation rule called. It's kind of a choke point to make sure your invariants, your business invariants, are always enforced. So let's see. So let's run our test. And you can see that our test is failing now. The first name that we were creating is actually less than 3. So let's go ahead and fix that real quick. And then it passes. You'll notice that we had a second test down here that kept passing. And that was using our factories. We'll look at these in a little bit more. But the reason it was passing is that by default, the factory happened to make the first name value be first name, and so that's why it passed. But so let's look just a little bit more about factories and then also kind of the workflow of working with Joist. So let's add 2 more entities. Let's go back to our migration, and we'll pretend that this migration hasn't been applied to production yet. And we're going to add reviewers that review our books, and then the book review itself, which has a rating of stars or whatnot for a given book and reviewer. And so your workflow with Joist, after making these in this project, the way we reapply them, maybe I already said that. We just do this make redb, and that reapplies our migration and then reruns our code generation. And so we should see, we see our new entities show up. So we've got our book review nice and clean, and then our reviewer nice and clean. And so, let's look at the book review test. Let's see, I do need to add the new Joist globals, which is fine. So you'll notice one of the things about the book review factory is that book reviews require a book, and the book requires an author, but we haven't had to create any of those. The factories just kind of handle filling them in. So this works out of the box. Obviously, you'd want to add, you'd only have tests for testing actual business cases, boundary cases, but here's the scaffold for you to start with anyway. So let's see, that's factories and kind of the domain models. Let's switch over to, besides validation rules, one of the things that domain models are nice for is kind of reusing business logic. So let's do that, but then also talk about kind of N+1 prevention. So let's go back to our author domain model, and we're going to add some business logic. You don't have to add them in the entity if you don't want. I'm just kind of going to do it for this demo. But we're going to count the number of reviews that an author has, number of book reviews. And so this is not amazing code, which is kind of the point, but this is our starting place anyway, of how it can be easy for ORMs to end up having a lot of code that looks like this, which is not very pleasant. But the idea of this is, we have an author, but we have only the author. We haven't loaded our entire database into memory, and so we kind of have to incrementally load bits of our database into memory to, perform business logic on it or display it to the client or whatnot. And so in Joist, the way that works is you have a books collection, and notice that the books by default we can't. The books. It's not the actual books in memory. It's not an array or whatnot. We have to kind of ask for it to be loaded. And we do that with the load method. So first we get the books. And now after we have the 2 books, let's say we've got 2 books, we want to, for each book, ask for its book reviews, which is what this is doing, which is going to be another await, which means we have, this await promise all, with the async to do another select star from user book. So we get the reviews back, that's fine. Part of our business logic is we don't want to count all reviews. We only want to have like quote unquote public reviews, which is where the reviewer is over the age of 18. just some random business logic. So we actually need to filter these reviews, but to do the filter, we need to load the reviewer. So that means we have yet another async operation. So we have another await promise all. I'm going to go ahead and console log that we're getting the reviewer just to kind of see how many times it's happening, because we're now, if we have 2 books and 2 reviews each, we're going to potentially load this, load 4 reviewers and then check if they're age. So that's the logic. It's not really great, but let's go write a test for it. So let's see, let's start out with this test. So we're going to count the number of public reviews. So this goes back to factories a little bit. This shows how, let's count the number of public reviews, given an author with 2 books. So we're going to make an author, and we're going to make 2 books. The first book has 2 public reviews. So the reviews, there's 2 of them. The first review was done by a reviewer over the age of 19, so it's a public one, and another public one, 19 to 20. And then the second book also had 2 reviews, so we've got 4 reviews altogether, but this third review was done by a reviewer under the age of 18. So this is a great example of the factory syntax, letting you create kind of a tree of data. Each of these reviewers will be a new reviewer, right? So we're going to be making 4 of them. Ages 19, 20, and then 17 and 20. So 2 of them will be age 20. And yeah, now that we've kind of set up our data, let's also copy paste in the assertion. So we want to call our number of reviews, and we expect it to be 3 because we don't want to count that one. And you can see that it passed. And this assertion is asking how many database queries did we do. What's kind of interesting is it passed. It did not actually do any database queries. So one of the things that Joist is smart enough with the unit of work pattern to do is realize that the author's new. And so like de facto cannot be in the database, and the books are new and the reviews are new. All of these things are new. And so it just knows it can skip doing a database query for the kind of tree of data that we wanted to look up. But that's not helpful for what we want to test. So let's go ahead. I guess I don't have that around to copy paste, but let's go ahead and send these to the database and then show what it looks like to load them back. So let's say, usually you don't have to do this in unit test. It's kind of an anti-pattern to have 2 entity managers for a unit test, but for the demo purposes, it'll be fine. So we're going to load back our author. This is almost like a new HTTP request. Oh yeah, let's do load. Okay, and now let's do the same thing. We're going to count the number of reviews, and now let's see how many queries we have. Let's see. Oh yeah, if I wanted to update, we'll go do this. Yeah, and so you can see that we've executed 4 database queries, 1 to load the author, which would have been this call, and then 1 to load the books, and then 1 to load all. So this would have been, 1 call to get 2 books for the author. And then you'll notice we just have 1 call to get book reviews. So we've combined both of the calls to get, the reviews for book 1 and the reviews for book 2 into just 1 SQL call. And then again, we were asked to load, if we look at our test output, our console logs say that we were trying to load 4 book reviews, reviewers for 4 book reviews, 1, 2, 3, and 4. But Joist combined those into just 1 SQL query. So it avoided the n+1 is where we're finally getting to, is that this is, super ugly code, but it's still safe. It's still safe. And so now, but it is ugly code. So before we close out the demo, let's just make, I can't really stand this, so let's clean it up. One of the big features that Joist has, we mentioned type safe relations. So what is that? So like by default, you have to load all of your relations, uh, but that's just the default. Let's say that we want to preload things. What we can do is use a populate method to say like, I know I've got some business logic. I want to populate my author because I know I'm going to talk to books and all of the book reviews and all of the reviewers. So you can use kind of this populate hint to get back an author that has been marked as loaded. So you'll notice in this little type hint here, it says it's loaded, it's the author, but it's been loaded with books and reviews and those things. Now, because of that, we can get rid of all of this async junk. And our author.books has a get method on it, which it didn't do before. Like if I did this.books, there is no get. The type system doesn't know that books is loaded, so you have to load it. But this is a map type that, the type system now is aware that we've loaded this data, and so we can get it without an await, which means we can treat them just, we can treat not only books as just a regular collection. You'll see that this get, returns a book array. We can treat it just like an array in memory. So we can start doing things like this. Which is saying for the book, for the author and the books, get all the books, and then flat map, just regular flat map over the book. For each books, get the reviews, but filter the reviews for reviewers where the reviewer age is greater than 18, and then count them. And, oh, yeah, filter and then count. So, that's the new code. Let's go run the test. Going to run the same test. And it had exactly the same behavior. So, still 3 came back. And notice that we still did the same number of SQL statements. So this populate hint is not necessarily saving a SQL calls, which is not terrible because our n+1 prevention already prevented this from being an n+1 problem. We made 1 query per level. So the big upshot is not necessarily performance prevention. We have performance prevention, performance guarantees built into the framework. Like even if you end up, having code executed in kind of ad hoc ways, it will not n+1. But in these little snippets, you can use these populate hints to write much cleaner code with just kind of, regular collections and those sort of things. And that is kind of the overview of Joist. It's about 20 minutes in. That's a little longer, but and lots more to cover, but is the basic intro of what we think makes Joist interesting. Thanks.